Professor S. Wijetunga from the Faculty of Agricultural Engineering, University of Ruhuna, and he's going to speak about bioenergy generation at home. I mean, that is one aspect. So we've covered wind energy, we've covered solar a little bit, and now really it's about bioenergy. And I think the first speaker mentioned the huge potential that is currently for bioenergy in the south, but that there's not much of it is being used, or not much of it has been generated in the north. So it'd be good to hear from what Professor Wijetunga has to say about it. His fields of interest are anaerobic digestion, waste management, environmental engineering, and he has numerous publications on agricultural byproducts, the use of them to generate energy, and he's also interested in water contamination and wastewater treatment. So Professor Wijetunga, please go ahead.
Yes,
Professor Raja, I think you have to stop sharing. That's it. Yeah, great. Thank you.
Yeah. Okay. Good evening. I'm Wijetunga, working in the Department of Agriculture Engineering, University of Ruhuna. So today, just within I think 10 minutes time, I hope to finish my presentation about biogas production at home. So actually now we listen to a lot of things about energy. So when we look at human history, we started from the wood as a primary energy source, and then we moved to coal and oil and gas, and then we use nuclear power. Now the time for the renewable energies. I think that is very important in terms of environment also, when we are shifting from that fossil fuel to renewable energy. So when we look at the energy production, so now as we listened earlier, in Sri Lanka also we pay more attention on the solar energy. At the same time, when we look at this graph published by the Shell International, we can see some still more avenues for the biomass energy and the wind energy. So when we look at the biomass energy, so we know that in Sri Lanka is still in the agricultural country. So we have enough biomasses for the energy generation. If agricultural products, forestry crops and so on, animal waste, basically a lot of waste material available we can use for the energy generation. So using the biomass, we know that we can produce a lot of secondary energy sources from the biomass. Today I am going to discuss about basically this part, biochemical transformation. Biomass, we can primary energy source, we can convert to secondary energy source through the biochemical transformation. There are two types. We can get ethanol as well as biogas. In the biogas production, so we have to use anaerobic fermentation process. So by anaerobic fermentation, we can convert biomass into biogas. Their main content, the gas in the biogas is methane. So methane we can use for the energy generation. So when we look at briefly the process of biogas production, so microorganism involved in this process. So then this microorganism consume the organic material. They produce methane as a byproduct. So then to produce biogas, so we have to use biomass, as well as we have to provide suitable environment conditions, basically anaerobic condition. So if we can provide this anaerobic condition, basically the anaerobic microorganism produce biogas. So the biogas, you can see about methane percentage, about 50 to 75%, and the rest is carbon dioxide is 25-50%. In terms of energy, in the today's topic, so methane percentage is very important. So because if you want to use as a energy source, so other trace gases also available. So main part is inert gas is the other gases carbon dioxide, but rest are hydrogen sulfide, ammonia, and so on. They are we normally don't care about, so that part should be very low. So our primary concern in the biogas production is to increase the methane percentage. So methane, I think we know that the energy is about 38 kilojoule per cubic meter. So based on the methane percentage of biogas, the energy value also changing. So when compared to the other natural gas and other major gas, the energy sources what we are using now, so biogas energy value is comparatively low. But however, so we using the biomass, basically we can easily produce biogas. We can use for secondary energy generation. So in the biogas production process, it is a microbial process. So I think in this process there are several steps. So the microbes convert this, the biomass into finally methane. So in this case, so when we select in biomass for the biogas production, so degradability is very important. So degradable materials easily convert microbes into the biogas, but woody materials such as the wood, the material having higher amount of lignin and then the cellulose, it take long time for the biogas production. So then those materials not suitable. So when we look at this suitable material, you can see that a lot of waste material we can use easily. So we know that in our homes we discard a lot of food waste, and then the same time in the farm activities we have animal waste and the byproduct of industries. A lot of things are there available in Sri Lanka. Especially in Sri Lanka rural areas, these raw materials are abundantly available, so we can easily use for the biogas production. So the biogas production, the biogas content percentage of this raw material is different based on the waste material. So the amount of biogas we can get a little bit changed. So you can see some the crop waste, the production potential here is a little bit changing, but all these material we can use for the biogas production. So in this process, simple diagram you can see here. In the case of production of biogas, we need to have a reactor like this, small one. Here is sketch, you can see it's small one. This reactor is used for the putting raw material. So then when we close this one, it is anaerobic condition. Then microbes convert this biomass to biogas. So then we can take it biogas, and then we can use as energy. So in the reactor, you have to have some provision for feeding raw material as well as removing digested material also. So using this concept, there are a lot of reactors developed in the world. A lot of reactors are there. In India, the pioneer of this technology, as well as China, they have developed a lot of type of reactors in the use of production of biogas in the domestic level. Right. So then basically you can see these two reactors are more famous one. This first one we call fish dome reactor, and the second one is a floating dome reactor. So this one, a floating dome reactor, is more famous in India. This one is more famous in China. But in Sri Lanka also, we also construct this fixed dome reactor because it is according to the available raw material, so we can easily construct this one. So in the rural areas, we can construct this one for the farmers or household. Then we can they can use this reactor for the biogas production. So you can see some construction step in these reactors. So easily using bricks and the cement, we can construct these reactors underground. So this the construction step. So the small domestic one, I'm concerned on this case. So small reactors we can construct. So then easily in the home waste material we can fed into the reactor, and then we can take the biogas. So biogas easily use cooking, boiling water, lighting, ironing, baking, dress, so on anyway. So now we encourage people to use for the cooking energy source as biogas, because in Sri Lanka, in the most of the homes now we have electricity. So then we don't advise people to use biogas for lighting, ironing, and so on. We advise them to use for cooking and boiling water and so on. So then once we produce this type of cookers, we can easily use, instead of LP gas, we can use this gas for cooking purpose easily. So lighting, earlier we encourage to use this type of lamp, but now we have electricity, so then we don't ask them to use this one. So after the biogas production, so then you can see the residual material after, the microbes cannot degrade all the raw material what we put to the reactor. So then remaining material, we can take it out from the reactor, so we can use as a fertilizer also. Organic fertilizer is a good fertilizer value. So then we can use for the agriculture this digested material as a organic fertilizer. So one we had some case, the study in the Matara. I am in the southern province of Sri Lanka. In the Matara, one farmer we selected is about 5 acres land. So we encouraged them to use biogas reactor because he had one cow. So using cow dung as well as their home waste, kitchen waste, they can produce biogas finally. So we advise them to use organic farming also. Then organic farming, they can grow vegetable for their day-to-day activities, as well as the remaining fertilizer we ask them to sell. So then a lot of demand is there. This study we did in 10 years, 12 years back. So he earned a lot of money for their by selling the organic fertilizer also. At the same time,
sorry, Professor Wijetunga, about 30 seconds. Can you wrap it up fairly quickly?
Yeah. Okay.
Don't mind.
Okay.
Yeah.
Okay. So then we advised, model reactors we develop in certain instances. This one is for the canteen of the Karapiti hospital we built in those times. So then the use for the biogas production. I think in Sri Lanka, basically dry areas, dry zone, north and east as well as rural areas, we can easily popularize this one for the people, for farming community, use this technology to get energy requirement as well as for the management of waste as well as for the fertilizer production. So thank you. So I thank you for, yeah.
Yeah, thank you very much. That is very, very interesting, that because we sometimes think of very high-tech solutions, but something more, if you like, related to the land and the result in using material from agriculture is something that's very useful and simple, which we sometimes need to remember that we could use that as well.
Okay, thank you.
Thank you. So now